All right, let's do some practice on percent increase and decrease with exponential functions. We're going to do numbers 2, 3, 5, and 6 on this video. Most of them have at least partly multiple choice. All right, number 2 says a population of 50 fruit flies is increasing by 6% every day. Which of the following is closest to the number of days it will take for the fruit fly population to double? Sorry, so let's go on through and see. So a population of 50 fruit flies. We want to write the exponential model. That's how many you start with, is 50. Now if you're increasing by 6%, that's going to be the 1 plus a percent. So 1 plus 6%, 0.06 to the x. That's the model. Now, it's not saying how much is there after 5 days or 10 days. They want to know how long until the population doubles. Now, what it's really asking is, if I start with 50, how long until I get to 100 fruit flies? So, a couple things you could do. I would just make a table on Desmos and figure out which number is closest. So let's try this. 50 times 1.06, or 1 plus 0.06, to the x power. Now, if I make a table, I want to see until my right column gets to be 100. So I'm just going to go through here and add in 3, not right there, 4, 5, 6, not quite to 100. So I'm just going to keep going. 7, 8, 12 gets me to 100. That was probably pretty close. Is that on my multiple choice? Yes, it is. So B would be your answer. Okay, it takes about 12 days till you get 100 fruit flies. Look at number 3. A radioactive substance is decaying. That means you're decreasing. We're going to be going down by 13% every hour. How much of a 200-pound sample is left after 1 day? So here's our model. We start with 200 pounds of something. It's going down by 13%, which means I'm going to take 1 minus the 13%. Now my exponent, I could put x, but I want to know how much is there after 1 day. We're measuring in hours, which means there are 24 hours in a day. So 1 day later would have an exponent of 24. I can go ahead and type this right into Desmos. So let's see, we will have 200 times 1 minus 0.13 to the 24th power. And it looks like there is about 7.07 pounds left, which is close to 7.1. So after 1 day of that 200-pound sample, there's 7 pounds left. Number 5 is purely multiple choice. It says, which of the following is a population that has an initial size of 625. It's growing by 8.5%. If you're growing by 1%, you have to be exponential. So I can actually cross off C and D. Those do not look like the exponential models that we've been working with. So C and D are not going to work. For A and B, they both start at 625. We have to decide which one of these growth rates represents growing by 8.5%. Remember, when you grow by 8%, you have to turn that 8.5 into a decimal, which, if you're not sure what 8.5 is as a decimal, take 8.5 and divide it by 100. That's 0.085. So then when I do increasing, growing by a rate, that means in my parentheses would be 1 plus 0.085, which looks like option B. 8.5 is not increasing by 8.5%. Okay, it's option B. And last one here, 6, similar kind of question. It says the acceleration of an object falling through air will decrease by 15% every second. The initial acceleration is 9.8 meters. Because I'm decreasing by 8%, I need an exponential model. A and B don't look exponential. So those are going to be ones I can eliminate right away. Anytime you grow or decrease by 8%. Now I have to figure out C and D. Well, here's an easy way to do it. Look at the growth rates. The first growth rate in C is greater than 1, so that means it's increasing. 0.85 is less than 1, which means it's decreasing, which is what we want. Now, just to go through it again, if I'm decreasing by 15%, it means I'm going to take 1 minus 15% is a decimal, which is 0.15. Well, here I don't have 1 minus 0.15, but I do have 0.85, which is the same decimal that I had in the answer that I chose. Right? We have a review coming up next. If you're having trouble with percent increase and decrease, ask your teacher for some extra help.